Now we talk about laws of refraction of light. So whenever refraction of light takes place, it takes place only under certain conditions. That means these laws will always be obeyed whenever there is a refraction of light takes place. So I have considered a ray traveling from optical medium 1 to optical medium 2. I can say AB is the incident ray, MN is the normal drawn at the point of incidence, and BC over here is the refracted ray. You can see this board is a two-dimensional plane, and on this two-dimensional plane you can see incident ray lies on this plane, normal lies on this plane, as well as refracted ray lie on this plane. That means the plane of incident ray, the plane of normal, and the plane of refracted ray, all the plane coincide. It means all the plane are nothing but the same. So we can talk about first laws of refraction, which states that incident ray, normal drawn at the point of incidence, and refracted ray, all three lie in same plane. If I talk about second laws of refraction, this states that for a given pair of media, that means whenever you talk about two optical medium, a ray traveling from one optical medium to another. For example, a ray traveling from air to glass, air to water, glass to water, water to diamond. So for two optical medium, I had said for a given pair of media, the ratio of sine of angle of incidence to the sine of angle of refraction. That means this is the angle of incidence and this is the angle of refraction. And for two given optical medium, the ratio of the sine of angle of incidence to the sine of angle of refraction always remains constant. That means this ratio will be constant for air and glass, this ratio will be constant for air and water, this ratio will be constant for water and diamond, glass and diamond. That means for a two given optical medium, the ratio of the sine of angle of incidence to the sine of angle of refraction is always constant. And this constant is called as refractive index. This constant is called as refractive index. I would write it by letter R dot I. So this refractive index of second medium with respect to first medium. So the ratio of the sine of the angle of incidence to the sine of angle of refraction is always constant, and this constant is called as refractive index of second medium with respect to first medium. And now this entire statement can be simply written by symbol mu2 of 1. So this is read as refractive index of second medium with respect to first medium, that indicates light is traveling from 1 to 2. Here you can say since light is traveling from 1 to 2, the ratio sin I by sin r can be written as refractive index of 2 with respect to 1. And this sin I by sin r, which is equal to mu2 of 1, is called as Snell's law. It's called as Snell's law. And you must be aware how to write this Snell's law for a given pair of media. If I say light is traveling from air to water, light is traveling from air to water, so if I apply Snell's law, you would say sin I by sin r. It will be constant, and this constant will be called as refractive index of water with respect to air, because light is traveling from, remember, air to water. And if I say light is traveling from air to glass, so how will you write Snell's law? The Snell's law can be given as sin I by sin r. It will be constant for air and glass, and this constant will be called as refractive index of glass with respect to air, because light is traveling from air to glass. I take one more example. Let's say light is traveling from glass to water. Now I have got two different medium. Light is traveling from glass to water. Even in this case, refraction will occur, and the Snell's law is given by sin I by sin r. Definitely sin I by sin r will remain constant. And here, since light is traveling from glass to water, the Snell's law will be given as refractive index of water with respect to glass will always be constant. Thank you.